Okay, good morning, everybody. Welcome back. Today, our 17th lesson, we are covering roots and radicals and rational exponents. So we spent a couple of classes recently talking about exponents and lots of properties of exponents. And then our last class, we talked about radicals and how to work with them, and we developed the product and quotient rules that we saw. And today we're going to connect those two topics together. Radicals and exponents turn out to sort of be one and the same. So that's what we're about today. Coming up not too far away. So this coming Friday, we've got new stuff. Monday coming up next week is just a catch-up day. I don't have any agenda for that day. We're just going to catch up and make sure we're solid on roots and radicals and exponents. Because as I mentioned, this is one of the hardest sections of the course for a lot of students. So that's what we're going to do Monday, and then on Wednesday is quest number 3, no calculator. Questions on the calendar? All right, then let's jump in here on page 134. In this lesson, we examine the relationship between radicals and exponential notation. All right, so there's an example written there. Let's just make up a different one right now. Let's go ahead and try the fourth root of x to the 36th power. See if you can squeeze that in there at the top. So we're just refreshing our memory for the technique from last class. So we copy that fourth root, we put some parentheses, and we say, what power would we really like to have up there? What power do I want to force up here? I really want it to be a 4, because then we know that the fourth root and the fourth power cancel, and the answer to this problem is just what's in the parentheses. So the goal is to figure out what goes in the parentheses. So we had some x's before, well, we still have some x's now, and we have to figure out what power on the x we have. And again, remember, we multiply the powers when it looks like this. So what power do we put in there so that we still have 36 x's at the end of the day? 9 is the power. We buy it. 9 times 4, that's the 36. And then, as we said, the fourth root and the fourth power cancel. That is to say, everything blue disappears. And what's the final answer here? What is it? X to the 9, right? All the blue stuff cancels, just x to the 9. Okay, and so then if we're looking for a shortcut, what can we do with the 36 and the 4 to get the final answer of 9? It's 36 divided by 4, isn't it? I mean, that's how we came up with the 9. We didn't think of it necessarily that way, but we were looking for a number to put in this box so that the box times 4 gives 36. Well, that's a division problem. So this is a brand new property for us, is that when you see a radical variable to a power, you can just divide. And so let's go ahead and fill this in general here. The nth root of x to the k is x to the, and it's going to be some fraction in here. We just have to make sure we put the n and the k in the right spots in that fraction. Where does the n go? That goes in the bottom, right? We did 36 divided by the 4. That 4 was the index. It goes in the bottom. K goes up on top. So a couple of stars there. That's our most important formula for today. So we'll just make up another 1 or 2 here. So for example, if I said find the 8th root of x to the 24th power. So we can translate this to a fraction. What fraction is it? What goes up on top here? That's the 24, and downstairs is the 8. And it turns out that goes in evenly. So x cubed is our answer. Okay? All right, but this property we put stars around works even if the number doesn't go evenly, like 8 went evenly into 24. But if you had the 5th root of x to the 8th, you can still do the property. You write x to the power goes up on the top. That's where the 8 is. And the index, the 5, goes on the bottom. So x to the 8/5. Even though the 5 doesn't go evenly into 8, still these two things are equivalent to each other, okay? So the moral of the story is that if you see a radical, you can translate that to a fraction power. And if you see a fraction power, you can translate that to a radical. We'll do both directions in just a second. Pretty much the only way to go wrong here is to put the 8 and the 5 in the wrong spots. So we just have to remember which one goes where. I came up with a silly little mnemonic device here. Remember the 5 is called the index. And so I came up with something here that says the index goes below deck. I'm thinking of the fraction as being like a ship, and the denominator is below deck. Index goes below deck. Also, flowers grow up, like upwards, and powers, that power 8 goes up in the fraction. Flowers grow up, powers go up. It's not my best work, but I don't know anything better. I was actually thinking about this last night, and if you play video games, you know the phrase power up. Right? Like maybe you get like an extra life, or oh, and Don walked in just at the right time. It's like, yeah, I'm all over that. Like a power up, maybe you get like a better weapon for your character or whatever. I don't know, power up, power up. The 8 is the power, it goes up in that fraction. If you come up with something better, please share so I can make this packet better for future students. All right, let's do 2 examples. Let's rewrite this radical, 11th root of negative 2y to the 13th. That is equal to negative 2y raised to the, you see a radical, you can write it as a fraction power. The index goes below deck, power up. So put the 11 and the 13 in the right spots. Hopefully we all got 13 over 11. It's okay. And then going the other direction in 4, rewrite the following in radical form, x to the 2/7. You see a fraction exponent, you could translate it to a radical. That's what we're going to do here. This one equals. So go ahead and write a radical sign. We got an x inside that radical. And we just have to put the 2 and the 7 in the right spots. Where does the 2 go? 2 is the exponent, that's our power, and the 7 is the index. Okay? All right. So the fraction property we just established there doesn't only work for variables like x's, it also works for numbers. And so for example, 64 to the 1/2, let's see if we can figure out what that really means. It doesn't mean half of 64. What it means, because there's a fraction power, is that there is a radical lurking behind the scenes here. So let's write that radical. Put the 64 in there. Where does the 1 go? That's the power exponent. Where does the 2 go? In the front, right? And so this is really saying the square root of 64. And normally you wouldn't write that 2, only in the case of a 2. And what is the square root of 64? 8. So 64 to the 1/2 is 8. So we've just figured out that a 1/2 power just means the square root of the number. That's it. Okay, let's take a look at the next one there. Negative 64 to the 1/2. Again, I see a fraction power, so I write a radical. What number goes inside the radical? Negative 64 in parentheses, just like it was at the start. That's important. Okay, where does the 2 go? That's the index in the front, and the 1 is the power, okay? So this is asking us to find the square root of negative 64. And at this moment in this class, we have no way to go any farther. The square root of negative 64 is not a real number. Can't take the square root of a negative number, at least not until we have imaginary numbers. So the answer here, this one is not real. It might be tempting to think the answer to this problem is negative 8, right? Maybe it's negative 8, but it can't be negative 8, because if the answer were negative 8, then when I do negative 8 times negative 8, I should get the negative 64 we started with. But what do you get when you multiply negative 8 by negative 8? Positive 64. So that's why any negative inside a square root is problematic for us. But compare that for one second up here to the cube root of negative 64. Pretend it were positive for just a second. What's the answer? 4. The cube root of positive 64 is just plain old 4. Okay, so maybe negative 64 is negative 4. Or maybe it's another not a real number. Well, let's just see what happens here. If this is correct, then negative 4 times negative 4 times negative 4, 3 copies, should give us the original negative 64. Does it? It does. So the answer to this one is actually negative 4. The answer is not a real number. It's negative 4. It's totally fine. What makes that one okay, but the square root no good? It was cube instead of square. And what's special about the number 3 that fails for the number 2? It's odd. That's it. Because we multiplied an odd number of negatives, we're able to get a negative out. But multiplying an even number of negatives will always turn your answer into positive. So that's the fundamental difference. Fourth root of negative 64, not a real number. Fifth root of negative 64, no problem. That's a real number. Okay, so it's an even odd thing. All right, let's take a look at C. Looks similar to B. Negative 64 to the 1/2. Okay, I see a 1/2. See a fraction, so I'll put a square root. What number goes inside? Negative 64? Just 64. Which one? 64 or negative 64? What goes inside? If we're not sure, remember what we said about exponents being really short-reaching things. What is the exponent touching? Just 64. And the exponent is not strong enough to reach that negative sign, which means that the 64 is in here. And where's that negative sign? Way out there in the front, unaffected by that power, which is about to become a radical. Okay, so now I've got 1/2. I've seen that before. 2 is the index, 1 is the power. What's the answer? Negative 8 is fine. Square root of 64 is plain 8. Negative sign is just copied. Big difference between B and C, right? 1 is not a real number. 1 is negative 8. Yeah, exactly. So like normally you would not write that 2 up there. The only reason we're writing it is that we've just learned what to do with fraction exponents, and so we're just putting it in the spot. And then for any number other than 2, you would need to write it, but in the case of 2, it's like you write it and then you say, oh, that's just square root. You don't even need to write it. Yeah. Okay, let's take a look at number 6. 6 is talking about 8 to the 2/3. Okay, so this one's written now. We're just going to read here. 8 to the 2/3. So we know that the 2 is the power and the 3 is the index. Everybody agree those are in the right spots? What is 8 squared in here? 8 squared, what is it? 64. So cube root of that is the same as cube root of 64. And the cube root of 64 we just saw is 4, okay? So 8 to the 2/3 turns out to be 4, no problem. Let's take a look at the order in which we did things here. First we squared, then we did the cube root, right? That was the order. Let's just see what happens if we do it in the other order. Let's first do a cube root and then let's square last, just to see. So this is the same exact numbers. All I've done is swapped the order of the square and the cube root. Cube root first, squaring last. Okay, what is the cube root of 8? That's 2. And then this 2, the square, is just sitting there waiting for us to do it. And when we do 2 squared, we get 4. And what do we notice about our 2 answers here? They're the same, and that is not a coincidence. It turns out that you can swap the order in which you do the root and the power. You can do them in either order, and you will get the same answer. And so this gives us an opportunity to make our lives easier. So let me show you how this is going to help us. If I think you have room at the bottom of your page, let's do this calculation, but we won't, we'll ignore it that it's written out. So right there at the bottom, just copy the 16 to the negative 3/4. Okay, so what I don't want to see is this. Don't copy this. People see a fraction and they say, oh, don't write this yet. See fraction, they say put a 16 there. Where do you put the 4? 4 is out there, and then the -3 is up there. It's okay, but I don't want to see that. I mean, the 16 and the -3 is kind of a mess. Another thing I don't want to see is a 3 there and the -4 there. Like a -4th root doesn't have any meaning for me anyway. So don't do either of those things. Instead, what I want you to do is first deal with the fact that is negative. Negative exponents mean move. This is currently in the top of a fraction, so we move it to the bottom. And when we move it to the bottom, what does the power become? Positive 3/4. Do write this. This is the first step I want us to do. And then we need a placeholder upstairs. What is it? That's a 1. And now that we've dealt with the fact that it's negative, we can handle that 3/4 power using our new technique. We'll rewrite it as a radical. So let's do that step now. So equals 1 over radical. 16 goes there. Where does the 3 go? 3 is the, 3 is the power, right? And then the 4 is the index. Okay, this is totally correct. But remember, you're not going to have a calculator on this next quest. And the first calculation we have to do for this problem is 16 to the 3rd power. That's kind of annoying if you don't have a calculator, right, to do 16 to the 3rd power. Although I will tell you, because I'm so smart, it's 4,096. Don't look over there. Smart. 4,096. Okay, but then even if you did the calculation to get 4,096, what would you still have to do next? Like right now, you'd have this. Don't write this part. You'd be at this stage. What would you have to do now? You'd have to find the 4th root of 4,096. Good luck. I don't know what that is. So there's nothing wrong with writing it the way that we've done here, but it does put us in an awkward calculation spot. But what we saw up above is that you could do the cube first and then the radical last, or you could do it in the other order and it's the same. So how about we choose this order instead? So get your eraser and write it that way. It's not clear that it's any easier, but it should give us the same answer. It's still okay. It's correct. Equals 1 over. All right, 4th root of 16, what is it? It's 2. Okay, well that was easier. And then all that's left here is 2 to the 3rd, and that's also easy. That's 8. So 1/8 is our answer. So I'm hoping I've convinced you. If you have to do arithmetic, you put that power outside of the whole radical. Do the radical first in parentheses, right? It's just much easier if you don't have the calculator. We would have gotten 1/8 if we had done it the other way as well, but it involves a lot more arithmetic by hand. Okay, one last example on the next page. Let's take a look at it. So here we go, 35x to the -1/2 over 20x to the 3rd, the whole thing raised to the -2nd power. All right, there's a couple of methods written out here. We're just going to read one of them. You can read the other one later. The one that I want to read is this first one. Okay, a few different approaches. My recommendation is that if you have a fraction, you simplify it first. So I am looking at this -2 and just kind of holding it off on the side. I will deal with that later. But for right now, I'm going to clean up what's inside as far as possible. So for example, 35 and 20, what common factor do they have? 5, right? 5 goes into both. 5 goes in 7 times and 5 goes in 4 times. So that is the 7 and the 4 that we have reduced to, okay? And then I see a negative exponent. I'm not really thrilled about that. So where can I move that? To the bottom, and it becomes x to the +1/2. There it is down there. There. And it's still in parentheses, and it's still raised to the -2. Okay, you are welcome to change this x to the 1/2 now to a radical. Fraction exponent could become a radical. But let's stay in exponent land because we have a lot of properties in exponent land. So what do you do with the powers when you see x times x? You add them. And so we're just going to add these powers. This is still us smushing together and making this fraction as nice as possible. 3.5, or as an improper fraction, 7/2. Okay? We have gone as far as we possibly can inside. Now we finally have to deal with this power. What I'm imagining here, or what I'm seeing here, is a fraction raised to a power. That reminds me of this property. Forget the letter. I think it was an M. Not sure. Anyway, that was one of our properties on the reference sheet. And we talked about this guy being the pseudo-distributive property where top and bottom both get the power. So that's what we're going to do here. We're going to give the 7 a power of -2, and we're going to give this whole thing a power of -2. And when I type this up, I actually didn't realize, but there's actually another property that I've omitted here, because technically it should have been something like this, the whole thing getting the power of -2. And then this is yet another property where you have two things multiplied together. And we pseudo distribute again, and both of those things get the power. And so I did skip a step here. But anyway, all three of these things end up getting that power of -2, okay? And now that they've all got the power, we are ready to do what with these powers here? What happens to those guys? We multiply those powers. And so multiplying those two powers, this is 7/2 times -2. And making it over 1 if you want. 2's cancel. And just get -7. So that is the new power right there. And then it's almost done. Any negative exponent we know we're supposed to move. So what happens to the 7? So 7 to the -2 moves to the bottom because it's currently on top. It changes to 7 to the +2. What happens to the 4 to the -2? Move that one up. X to the -7, move that one up. Now the exponents are all positive. That's wonderful. And then finally just do the calculations. 4 squared and 7 squared become 16 and 49. I think I've said this before. For sure, I will say it again. What you see there is that a lot of good habits in algebra involve copying almost everything and making one small change. Every step of the way, we did a lot of copying and made only one small change. And all too often, I see students that know what they are doing, but they try to do 2 or 3 steps in one shot instead of just copying everything except for the one thing they want to focus on. Okay, I think that one's good there. Activities start on the next page. I will walk around.